Ionic equilibrium part 2. This is the subtopic in ionic equilibrium. Lesson outcomes. At the end of this lesson, students should be able to define salt and salt hydrolysis, calculate pH, BOH, and degree of ionization for strong or weak acid and base, calculate pH and BOH for salt. pH is a measure of the concentration of hydrogen ion or hydronium ions in a solution. The unit is molarity, m, molar, or mole per cubic decimeter. The molarities of hydrogen ions are high for strong acids, low pH, and low for weak acids, high pH. So this is the formula for pH is equal to the negative log concentration of hydrogen ion. So this is also same with the hydronium ions. And we look at the concentration of hydrogen ion is equal to antilog negative pH. Strong acids, pH of dilute solutions. We look at this. This is the strong acids and how you calculate the hydrogen ion concentrations. So we look at the 1 mole of the hydrogen ion. For every 1 mole of the HX is the general term for a strong acid. So thus if 0.040 molar perchloric acid, so how you calculate the pH? Look at the hydrogen here, it's only 1. So meaning that the hydrogen ion concentration you just times with 1, multiply by 1. So 0.040 molar and use these concentrations in the negative log 0.040 and you get 1.40 for the pH. If you look at the sulfuric acid here, they have the 2 hydrogens, so meaning that the concentration multiplied by 2. BOH is a measure of the concentration of hydroxide ion in a solution. The molarities of hydroxide ions are high for strong base and low for weak base. This is the unit for hydroxide ion in concentrations. So this is the BOH is equal to the negative log, the concentration of hydroxide ion. If you want to find the hydroxide ion in the concentrations, so equal antilog negative BOH. pH of dilute solutions of strong base. This is the example of the strong base. So this is the 1 mole hydroxide ion. For every 1 mole MOH, this is the term for the strong base. We look at this one. This is the 1 mole OH. Same goes here. And if you look at the calcium hydroxide, we have the 2 mole hydroxide ion for 1 mole of this compound. So meaning that the concentration of hydroxide ion you need to multiply by 2. Example, calculate the pH of 0.00011 molar calcium hydroxide. This is the chemical equation of the calcium hydroxide. And we look at the hydroxide ion They have a 2 coefficient here. So if you want to identify the concentration of hydroxide ion, you must multiply by 2 for calcium hydroxide because they have a 2 here. Okay, and if you want to identify the pH for the calcium hydroxide, you need to find the pOH first. So, to find the pOH is equal to negative log the concentration of hydroxide ion is equal to the 3.66. Then, you find the pH. Use the formula pH plus pOH is equal to 14. So, the 14 minus pOH, you get the 10.34. If you want to find the concentration of hydrogen ion, so the concentration of hydrogen ion equal to the antilog negative pH, which is the 10.34 is equal to the 4.6 exponential negative 11 molar. Redefine acidic, basic, and neutral solutions in terms of pH. As pH increase, the concentration of hydrogen ion decrease and pOH decrease, and for the hydroxide ion, the concentration is increased. As pH decrease, the concentration of hydrogen ion increase, pOH increase, and the concentration of hydroxide ion decrease. Neutral has pH equal 7, acidic the pH less than 7, and for basic the pH more than 7. The ion product constant for water Kw. So this is the formula. At 25 degrees Celsius, Kw is equal to the concentration of hydronium ion or hydrogen ion multiplied with the concentration of hydroxide ion is equal to the 1.0 exponential negative 14. So pH plus pOH is equal to the pKw is equal to 14, and pKa plus pKb is equal to pKw equal to 14. Weak acid or past equilibria. So this is the chemical equation for the weak acid. And we look at the Ka. Ka is equal to the concentration of the product divided by the concentration of reactant. Ka is equal to the acid ionization constant. pKa is equal to the negative log Ka, and Ka is equal to antilog negative pKa. This is the table for Ka and pKa values for weak monoprotic acids at 25 degrees Celsius. Reaction of a weak base with water. So this is the chemical equation. When you look at the Kb, so the water concentration of water here is constant. So we can cancel out this. And this is the formula for the Kb. Kb is past ionization constant. To find the pKb is equal to negative log Kb. And to find the Kb is equal to antilog negative pKb. This is the table for Kb and pKb values for weak molecular base at 25 degrees Celsius. Degree and percentage ionization. This is the percentage of dissociation for weak acid and also the weak base. This is the formula. So percent dissociation is equal to the hydronium ion, the concentration dissociated, divided by the concentration of hydronium ion initial with times with 100%. So this is the same with the weak base. So for the weak base, this is the hydroxide ion. This is the example for weak acid, how to identify the percentage of dissociation. This is how you determine the nature of the solute. The only solute is a weak acid. This is the only solute is a weak base, and the solute consists of both a weak acid and a weak base. This is the example how you indicate the pH of a solution with an initial concentration of 0.2 molar hypochlorous acid. This is the solution. We look at the ICE, the initial 0.2 molar. The change is negative X because this is the 1 coefficient. So equilibrium 0.2 minus X. For this one, you assume the X is small. Approximate this one is 0.2, so you can cancel the X here, but not this X. Okay, for this one. So you get the answer for X is equal to 7.74 exponential negative 5. And we look at this one for the hydronium ions is equal to the X. So the concentration is equal to the 7.74 exponential negative 5. And you can find the pH of the concentrations. So the answer is 4.11. So this is the exercise. You can try to do it. How do we measure pH? We use the pH meter, acid-base indicator, and litmus paper. Hydrolysis reaction. This is the definition of salt and salt hydrolysis. This is how you identify the pH of salt solution. Neutral salt. Salts containing an alkali metal or alkaline earth metal ion except beryllium ion and the weak conjugate path of a strong acid such as chloride, bromide, and nitrate. Their salt dissociates completely in water and does not undergo hydrolysis. Acidic salt form when strong acid react with a weak base. The hydrolysis reaction produces the hydrogen ion. For basic salt, neutralization reaction of weak acid with a strong base. The salt which contains conjugate path of the weak acid, the hydrolysis reaction produces hydroxide ion. Hydrolysis, yes or no? Metal ions of alkali metals, such as the lithium, sodium, potassium, or alkaline earth metals, do not hydrolyze, and ions which are conjugate paths of strong acid do not hydrolyze. Ammonium ion and hydrated metal ions hydrolyze to form hydronium ion, and ions of weak acids hydrolyze to form hydroxide ion. This is the example of acid-base properties of salt.